There are two goals to my model making process. The first goal is to create the most amount of detail possible with the fewest number of polygons, because that allows the model to be viewed and enjoyed and displayed online. The second goal is to save me time by creating the largest and most detailed model possible in the shortest amount of time. Now, both of those goals are accomplished through components and through what I'll show you here, an example of rotational geometry. Here's what I mean. When I click on an individual part of the building, you'll see that there are layers and components. And when I go down to the base layer for the tower, it's one component. And let me pull out that component from the building so that you see what I mean. Here's that component. The entire tower is made up of one component, which is a section of 1/8 of the tower. This is just 1/8 of the tower. And it has a simpler geometry. And so by creating 1/8 of the tower instead of the entire tower, what I do is I take this 1/8 of it and I'll copy it and paste it in the same place. Paste in place. And now when I scale the model, and I mirror it, the same way that I mirror the model with that image texture, I get 1/4 of the tower. And now when I do that again, and when I rotate it, I'll copy that, and I'll do paste in place, and now I'll rotate the whole thing. Let's rotate it 90 degrees. Now I'll rotate it and align it to the center. Now I have half the tower. And I'll do that again. I'll select the entire tower. I'll copy it and I'll paste in place. And now I'll rotate it again. I'll align it. And you'll see that a 1/8 section of the tower, that is, very few polygons, have become a lot of polygons. So that just by creating a small section, I've created the rest of the tower. And it's very easy to add more details onto it. So for instance, if I add a little rectangle or a triangle to one section of the tower, to 1/8 of the tower, that detail will appear on all the other sections of the tower. So this little triangle that I just added appears everywhere else. Like that. And not only can this process of using rotational geometry save you time and the number of components and the number of polygons for the tower, this can also be used for all manner of other parts of the building. So for instance, these columns have rotational geometry. So when I zoom in, you'll see that I didn't create the entire column, I only created 1/4 of the column. And I've rotated it. The same thing goes for the vaults. When I click on a vault, I didn't create the entire vault, I just created 1/4 of the vault, which you see highlighted here. I created 1/4 of the vault, and then copied it the length of all the arcade for all the vaults. So therefore, just by creating one small component, right here, which actually just has two sides, side 1 and side 2, by rotating that 1/4 of a vault to get an entire vault, and then by multiplying that vault in rows and in columns, I produce an arcade of a lot of vaults. And what this means is that you can produce very geometrically complex forms with simple component elements. And this is another way to save time, and to save on components, and to save on geometry. And these are all reasons why this pretty complex model is actually made up of very few parts. The same thing goes for this spire. The spire right here is only made up of 1/4 in 1/8 sections. Here you see 1/4 of the spire of this little tower that has been copied endlessly. And same thing goes for the central spire, which is divided into, you guessed it, 1/8 sections. The entire model is made this way, with small components, with few polygons, that have been strategically designed that they can be rotated, copied, and pasted in ways that create complexity. And this process can be applied to this model optimized for online use, as well as any other model you create.